Hi, everyone. Welcome to our third week of class. In this week, we are going to be moving into units 6 and 7. Unit 6 is all about natural resources. We're going to be talking about the different materials that we gather and use from the earth. And a lot of this information is going to depend heavily on the information that we have talked about in the past, in the previous weeks. And so scrolling down, we've covered plate tectonics as well as minerals and three different types of rocks. And now that we have that information, we can begin to think about the different materials that we use to create the society that we have. So in this lecture, we're going to be talking about various natural resources, including things like coal, oil, natural gas, as well as things that we get from mining and resources that we find here in Tennessee. So jumping over to our slides, again, remember that we do have those keywords, that sheet of keywords, as well as a link to the quiz and your photo journal for this week. The essential concepts here really focus on understanding where our natural resources come from. We're going to spend the first half of these lectures looking at those natural resources that are based in coal. These resources we use for energy, and it's a very important topic when we consider things about the environment as well as the cost of living and what we need to run our society. Then we'll talk about resources that are mined from the earth, where we gather those resources, the ways in which we gather those resources, and what we use them for. And then we'll give a brief overview of the different materials that we find in the state of Tennessee. So here we go into lecture 1. What are carbon-based resources and where do they come from? So carbon-based resources. These resources represent stored energy. Carbon-based resources are energy that takes three different forms. We're going to talk about the three different forms of this carbon-based energy, and they're going to be the solid, liquid, and gas forms. For the solid, we're going to talk about coal. For liquid, we're going to talk about oil, which is also called petroleum. Sometimes we call it gas at the gas station. It's not really a gas, it's a liquid. And then when we talk about gas, we're going to talk about natural gas called. All three of these forms of carbon-based energy once were organic matter. They were once living material on the earth, and it has now been stored inside the earth. And when we think about this, we're not thinking about dinosaurs or animals. Mostly what we're talking about is plants and plankton in the ocean. We'll talk about how this material is converted into energy and into these materials a little bit later. Now, why do we use the term fossil fuel? So it's not because they come from dinosaurs. These are not dinosaurs. This is not the decomposed remains of a stegosaurus or whatnot. These materials are called fossil fuels, one, because we use them for energy, so that's the fuels part, but then the fossil part actually represents that this material was once living organic matter, mostly plants as well as organisms that lived in the oceans. So that's where the fossil comes in, because it is a representation of a formerly living organism, but it is not from any sort of like dinosaurs or whatnot. These are all going to be found inside sedimentary rocks. That is sort of the area or the type of rock that creates the best conditions to transform this organic matter into the energy that we use. And as you can see from this chart here, let's see here. Yeah, just been a big X through that dinosaur. This one is a little bit of a joke. Like this is saying that this is the oil and that's the gas and it's a dinosaur farting. Not how it works. Um, this is basically showing that each and every year we have continued to produce and use more and more of these carbon-based fossil fuels. Up here is natural gas or liquid gas, natural gas, and then coal. And then down here, things like various other forms of energy, and nuclear is not growing as fast as these other ones. And so the dominant form of energy on our planet, the dominant form of energy demand on our planet is directly related to these fossil fuels. Okay, so let's jump into the first type, which is coal. Coal, or I should mention, when we think about this energy, we want to ask ourselves, where did the plants and this plankton in the ocean, where did they get their energy from? Plants grow through photosynthesis, and photosynthesis is a process where these organisms are converting energy from the sun into energy that they can use in their inside the plants. Similarly, plankton also convert energy from the sun and use that to use in their bacterial or inside their organisms. And so all of this energy that is now stored in these fossil fuels originally came from the sun, which I think is really, really interesting, that the primary source of energy, the starting point for all of this, is the sun's energy. It has then just been converted into organic matter and materials through these different organisms. So maybe that helps us to think about what energy is most available to us on this earth. It's probably energy from the sun. However, that doesn't mean that that's the most energy that we use. We use these fossil fuels far more abundantly than we use solar energy at the current moment. Okay, so getting into coal. So just a little, wanted to touch on that all of these organisms, all this plant matter is getting its energy from the sun before it gets converted into fossil fuels. So coal formation usually begins in an environment that is in a very low topographic area, usually like a swamp, something that is adjacent to large bodies of water. And these swamps are important because they contain water that is devoid of or very low in oxygen content. The organic matter is able to break down into its constituent pieces, but it isn't consumed by the bacteria that is living there because it is so oxygen poor. This creates a very rich organic material called peat. The peat material is like the nasty organic mud and gunk that is sitting on the bottom of these swamps. It's just full of dead plant matter from these different trees and plants and different leaves that have died and fallen in these environments. So this material is sort of the raw material that goes into forming coal. Once that peat unit or layer is buried by other layers of sediment, it goes through a process very similar to what we talked about in our unit on metamorphism. That material is buried, and so it goes under an increase in temperature and pressure. This usually takes millions of years for that material to be buried and compacted, and for the temperatures and pressures to start to increase. As the temperature and pressure increases, the organic peat becomes compacted and essentially baked into different varieties of coal. So that process is essentially removing the impurities that existed in the plant matter and leaves only the organic material that we know then to be coal. So there are several grades of coal that I want you to be familiar with. Here is that starting material, that peat material, and it has the highest proportion of water and other impurities and the lowest percentage of carbon. However, as we bury that peat and as that peat becomes enriched in carbon, we begin to see these other grades of coal emerge. The process continues to purify the coal as it is subjected to different temperatures and pressures. So as the amount of temperature and pressure increases, we are able then to transform that peat into other grades like lignite. Lignite has more percentage of carbon, and so it is more enriched in the fuel that is used for this material. Bituminous is a higher grade of coal. It has the lowest amount, a low relative amount of water and impurities. And then the purest form is this anthracite. It has the highest amount of carbon and the lowest amount of water. And as you can see, it's completely shiny. This is that metamorphic, this carbon material that has gone through that metamorphic process of heating through temperature and pressure to concentrate all of that carbon material into this new rock that we call coal. Okay, so how do we access this coal? Well, there are a variety of different mining techniques that excavate and bring coal either from buried deep down below or access it readily from the surface. So methods for getting coal from underground mines include these shafts that take down the equipment down into seams, these layers of coal, and those are excavated sometimes through these really large robotic trenchers or scrapers. And then the elevator is then bringing the coal up to the surface. So this can happen in a shaft mine or a slope mine. Other forms of mining might be on the surface where they could take parts of a mountain off of this mountaintop mining, which is not really great. We don't like to see mountains destroyed for this. But ultimately, what ends up happening is that large cranes are used to drag their buckets along the surface to pick up this coal material. Oftentimes, this is called strip mining because it is taking off entire layers of the surface or the mountaintop, which isn't really great to see. However, it does produce a lot of coal really quickly because it does not need to be transported back up to the surface. So here's a look at what a strip mine looks like. And as you can see, there is a lot of these coal layers that are readily available at the surface. And so these cranes basically work to drag the material over the surface, drag their buckets over the surface to pick up the coal and place it into the dump truck. So this is a very efficient method for accessing coal. So where is the coal located? So this is going to show us a map of the different grades of coal. Remember, anthracite is sort of the most pure and the most enriched form of coal. That's going to be shown in yellow and gold. And so these areas, such as in the North Dakotas or in the Alabama, Mississippi, Louisiana, these areas have larger amounts of anthracite. Areas with lower grades of coal include the Appalachians, as well as the plains, interior states, and then some parts of the Mountain West. So states like Wyoming and Montana are top producers of coal because they have access to readily to grades of coal that are really enriched. And so they're able to get more out that is more efficient and more profitable. As you can see here, the different grades of coal need to have a minimum thickness of those layers for them to be profitable to mine. These higher grades, the anthracite and the bituminous, only need to have a thickness of around 14 inches for them to get a profit off of those mining operations. However, for the grades of coal that are less than this, like the lignites, which are have more water and more impurities, you need a thicker layer of coal to make the mining process profitable. Now, how is coal used? Coal is burned, and it is actually the most abundant fossil fuel in the world. It is burned to create is burned to create heat, and that heat is used to heat up water, and that heated water creates steam. The steam turns a turbine that then generates electricity. So here's an example. There will be large mountains of coal that are then sent into the furnace. That furnace will then heat up the water to create steam, and that steam will spin a turbine, and that turbine will then generate electricity, and that electricity will be sent to the cities and the homes and the businesses that are using it. China is the #1 producer of coal in the world, right behind the United States. And this is almost $1 trillion industry just in this version of fossil fuels alone. It usually is used to make electricity, but there are also some other byproducts of this process, including the manufacturing of cement. As of right now, the United States has coal reserves that will last it around 250 years. However, the next slide we're going to talk about is going to talk about the environmental consequences of burning coal. So what are the problems with coal? The mining processes are not great. The mountaintop removal mining destroys the tops of mountains, making basically the landscape pretty ugly, which is really unfortunate. Also, this process can pollute and contaminate waters with the very toxic chemicals that are used in the mining process. This is called acid mine drainage, whereas the acids that are used to extract some of the resources end up in the water supply for these areas. Also, these jobs can be pretty dangerous and have long-term health effects. A lot of this material can break down into dust, causing lung diseases, and that mines sometimes can be unstable, leading to collapses or some failures like landslides. And also, coal burning is the biggest contributor to CO2 in our atmosphere each year. So there are a lot of problems with coal, even though it is relatively abundant and cheap. It really isn't the best thing for us as a society and as a planet.